Okay, welcome to this webinar with TomTom and Miovision. We're going to give everyone just maybe a few more minutes or a couple more minutes just to get settled and join in, and then we'll get started. Okay, let's get going. So welcome along, wherever you're dining in from. Good evening if you're with us in Europe. Good afternoon, good morning if you're in the US or in the Americas somewhere, and somewhere in the middle. Hello and welcome. Today's webinar is joint with TomTom and Miovision, and we're going to explore how traffic management is being revolutionized with TomTom's products and services alongside Miovision. Let's move forward and get everybody introduced. So my name is Andy Marchant, and along with Doug Gilmour and Thomas Bauer, we're going to take you through a range of topics in the next hour. It's a little bit interactive, so we'll be launching a couple of polls as we go through for you to give some information on, and there'll be a section on Q&A towards the end, but you don't have to wait till the end. Please add your questions in as we go to the box there on the right hand side of the screen, and we'll pick those up towards the end. But before further ado, maybe I can make a couple of introductions. So Doug, do you want to maybe just give a couple of words about who you are and what you do?
Sure. Hi there. My name is Doug Gilmour. I'm a Strategic Business Development Manager for TomTom, and specifically focused on the traffic and travel products portfolio in TomTom. And my job is to find and work with partners like Miovision to deliver better experiences and to help our end customers in the road agency, DOT sector, in traffic management, and in traffic analytics. Thomas.
Okay, well, thanks, Doug. Thomas Bauer, as the title says, General Manager TTS at Miovision. The TTS comes because I was the founder and CEO of Traffic Technology Services, TTS, and we were acquired by Miovision just about 4 months ago, and since then we are part of Miovision. Thank you, and very happy to be here and for that opportunity from TomTom to make this be part of this webinar.
Thanks both. Thank you. So here's the agenda that we've got for the next hour or so. So we're gonna talk a little bit about traffic management with both SPaT and GLOSA. Then we're going to look at about the management and the role of real-time traffic and historical traffic with vehicle to exchange. And then we're going to have a little bit of a discussion about how TomTom and Miovision are helping businesses and governments with their solutions and with their products. As I say, please pop your questions in as we go along, and we'll get to a Q&A towards the end. For those who are maybe not as familiar with TomTom or maybe joining for the first time, maybe let me tell you a little bit about who we are and what we do. So really at our core, our essence is we are map makers, and we really have this vision to build the world's most smartest, most usable map. We provide our location data and our technologies to car makers, to businesses, to developers, and our application-ready maps with routing, real-time traffic, our APIs and our SDKs are really there to inspire innovation and really help move the world forward through different use cases, different applications with our customers. So maybe onto the traffic side. Doug, do you want to tell us a little bit more about the traffic products?
Sure. So an increasingly important part of the digital representation of our reality of our world is enabling the presentation of dynamic road data and understanding what's happening in real time. And so to that end, TomTom is building upon those maps, building upon that static spatial picture, and building live speed data, live. We provide live incident data. We detect incidents and events on the road network in real time, and we allow traffic managers, road network operators to monitor whole areas, their entire city, or individual routes using the route monitoring product. And then on the flip side, we also enable historic traffic analytics, or an analysis of historic conditions, historic traffic movements between origins and destinations or across an individual road link. And the final product here, intersection monitoring, really goes into extreme detail, some micro level analysis of movements at an intersection, particularly signalized intersections where things get very stochastic, where there are delays on individual approaches, where both managers and partners and those with technology like Miovision want to understand how drivers are affected and communicate with those drivers. So intersection monitoring is kind of the focus of what we'll be talking about today, and the ability to dive in and capture real-time information at that level of spatial detail.
Great, thanks. Thanks for the insight, Thomas. Miovision.
Sure. Well, thanks, Andy. Well, let me start out saying that Miovision is almost 20 years old. The company started by basically setting out to change the way how traffic data was collected and integrating basically now real-time historic data into advanced analytics to really improve the mobility for all road users, not just cars, but also pedestrians, bicyclists, and, as I said, all motorists. Having said that, moving from, let's say, an initial data collection company to really an ITS company, and then later on now with the acquisition of TTS to also a V2X company, it really has, let's say, opened up the portfolio. And you see that now, for example, here, in terms of the number of locations we have counted over the years. We are best known, actually, I would say, in terms of a brand for the Opticom brand, market leader for emergency and transit signal priority systems in North America. And with that, let me also highlight the top left number here, 2 plus trillion SPaT messages delivered. That's the number of SPaT messages that we are or have been delivering to our customers over the last 10 years as a service. And obviously in the next few slides, we're going to dive in deeper what a SPaT message actually is and how this whole service works.
All right, great. Thanks. Thanks for the insight and the background. And there's certainly some big numbers. Some big numbers on there. Interestingly, last week we made the joint announcement of our collaboration and our partnership. I don't know if you could just take a couple of minutes just to maybe talk about why Miovision chose TomTom.
Yeah, that's a fair question. It's actually a relatively easy answer, right? For us, how do I say that? Coverage of intersections for our SPaT service is very important. I didn't mention it earlier, but we are best known in terms of the SPaT service for Audi. That was our launch customer. We are live in Audi commercial vehicles since December 2016 in North America and have expanded our service almost certainly into Europe now and even into China. And with that, coverage and global coverage is very, very important. So for us as a data vendor, TomTom provided that opportunity. We have a global access to their coverage all over the planet, basically. The second and just as important aspect to the global coverage was unmatched penetration and sampling rate. There's no other data vendor that I am aware of, and we looked quite extensively, that has the number of data points, the sample size, if you so will, that TomTom had and that we can now take advantage of. And the third one is also important, maybe not as, let's say, flashy as the first two I mentioned, but the workload. TomTom basically is pre-processing a lot of the data for us, taking over part of the workload that we otherwise would have to do ourselves. And that is obviously a cost consideration and a value proposition that was unmatched by anybody else.
Great. All right. Well, hopefully it's the start of a beautiful relationship and can grow and grow as we go forward. But let's move on and let's maybe get those listening involved as well. So thinking about how many journeys you make on a regular basis, be that regular everyday commute or somewhere that you travel to, weekly, monthly, etc. Just give us a bit of an indication about how many intersections or traffic signals do you think you encounter in a day. Doug, what about you? What number are you going to pitch for? Where are you sitting?
Well, since before COVID, I've worked from home and travelled from there for work and business. So for me, it's the only intersections I encounter are with my kids and the stairs.
Doug, what about you?
Thomas.
Sorry.
Similar,
sorry.
right?
Sorry.
It was never more than 5, to be honest with you, or 6. But it's yes, I'm very lucky. I don't have a very far commute. However, those 5 are part of our service, and so they become not only a commute, they also become a test, right? A live test all the time. Go driving through it, see that your service functions properly and that everything is good.
Yeah, I'm in the bottom bracket. I think I live in a very small town. I live in a very, very small town, and whilst we have some traffic signal junctions and some, I guess, partial complex junctions with the way the traffic light systems are set up on roundabouts and things like that, it isn't big, and it isn't very many, to be fair. Would be interesting to see, maybe think about how many people did pre-COVID times, and when working from home wasn't maybe quite the norm. But looks here like we've got a kind of 6 to 10 is about the winner at the moment. Everything else, the others are pretty much equal.
More than 22 though. It's also pretty high. The lowest one.
Yeah. So
well distributed.
Good. All right. Thank you. So moving on then, let's go to the first topic, where we're going to look at signal phase timing and green light optimal speed advisory. I guess warning to everybody on the call. I think already so far we've had quite a few acronyms with SPaT and V2X, etc. And maybe Thomas then for SPaT, which I think is what we're going to kick off with. It may mean different things to different people. Some people know what it is. Some people don't know what it is. Can you maybe explain a little bit more to us?
Absolutely. Let me. Go to this slide. This is, as you just said, right? SPaT means a lot of things to many people. In fact, I would say over the past few years, let's say the last 5 years or so, you won't believe how many people use the word SPaT. And what it turns out to be is that, as you said, many people have different ideas or conceptions of what it actually is. So let me highlight here in this slide. It's a standardized message set. It was standardized by Society of Automotive Engineers. It's J2735. Stands for signal, phase, and timing. It's a dynamic, so real-time or pseudo-real-time message set. And it includes, of course, information about what's the current state of the signal or an individual signal group. Is it green, yellow, red? All of those components. But most importantly, and that's why it's highlighted here in bold, it's the predicted signal switch times, right? The most important part for applications that we are using or that are being developed upon that SPaT message is, okay, it's green right now. Well, how long is it going to remain green? And if I'm predicting that length or that next switch time, what is my reliability of that prediction? Because most traffic signals or a lot of traffic signals are dynamic. So you want to know, what is the reliability of that prediction? Is it high? Is it low? Where does it fall into? So that the use case that is built upon this SPaT messages can really take the best and get the most value out of it. Moving on to the evolution, since this is really how SPaT messages sort of have developed and the concept of a SPaT message over the time. I would say initially it was, of course, conceived as a super low latency, locally broadcasted message set. But then it has been evolved over various different ways to develop a SPaT message. And so we at Miovision basically decided to create a new terminology of SPaT messages. We basically are calling UD, ultra high definition, for the very low latency, locally broadcasted message. HD for high definition, the SPaT message that is, let's say, generated through a network connection to the individual signal controller, but not locally broadcasted. And then, let's say, communicated to a vehicle via cellular communication. And then even a standard definition, SD SPaT. And that SPaT message is actually crowdsourced. And that's, of course, why we're talking about here. It's the relationship and the cooperation with TomTom. And most important is that SD SPaT concept allows us to scale, because what has held up this entire industry, V2X, for the last 30 years, even to the point that some car makers probably gave up on VTX and said it will never happen, is the lack of scale, right? And this concept of an SD SPaT, where we work together with TomTom or companies like TomTom here, allows us to really develop SD SPaT message at scale to really get into closer to a full intersection coverage.
Okay, thank you. And GLOSA is another one, right? Another acronym that we've got. Maybe you want to just take a few minutes to explain that, and really what's the impact of this technology? What are the kind of the applications or use cases?
Absolutely, and it's another one, as you said earlier, where a lot of people use GLOSA, and it has different meanings as well. But most importantly, it stands for Green Light Optimal Speed Advisory, right? The idea is to give, or the concept is to give the driver information about the traffic light that the driver is approaching in the distance, and basically provide, how do I say that, a predictive information about what the signal is going to do, and then advisories say slow down, continue your speed, or prepare to stop. You will arrive at a state of the signal that you know in advance. And of course, with that knowledge of the predictive information, that knowledge in advance, we can save fuel consumption, minimize stops, etc. And in fact, we have a video. The next slide will show you a video where you can follow along as we approach a traffic light in an equipped Audi in this case. So here we are in the lower part. You see the dashboard, the cockpit, or virtual cockpit of the Audi. It tells us the speed limit is 45. And we're expected to drive 45 miles per hour. You see in the distance, the red signal. This is the signal we're approaching, but our car already knows by the time we'll get there, the signals will turn green. And you saw it just turned green way in advance to our approach. We don't have to stop. We can basically continue right through. And we knew about this way in advance, almost half a mile in advance of that traffic light. In the top left corner, and I don't know if that's video will recycle briefly because it just does. Top left corner, you see our back end. This is the digital twin of that intersection. It's as I said, a digital copy of it, and it mimics and simulates the exact control of that intersection itself. And it knows, therefore, already when the signal is going to change. It predicts that change and sends that prediction through a SPaT message to the automotive customer, in this case Audi, that then displays it inside the vehicle for the driver to take advantage of it. And in this case, save a spot.
Nice. Thank you. Okay, so maybe a question to the people listening again. So thinking about what you've heard there with GLOSA, what do you think it can do for your use cases in your cities, businesses, etc.? Type your messages in, and we'll have a look at a couple of those in a minute. While we wait for you to put your ideas forward, maybe Doug, do you want to just maybe give us a little bit of a summary about what do you see some of the benefits of GLOSA being?
Yeah, sure, absolutely. So yeah, this is very exciting technology, and it's distilled down into that little green light indicator in the example we just saw in the Audi vehicle. But it's also really interesting that SPaT, time to green timing information, the digital twin technology that Thomas just alluded to, and and to this live in-vehicle navigation system. All three applications of this data, connecting SPaT with GLOSA and digital twins, is right at the heart of the technology that TomTom provides. Maps, live dynamic data, and services. So what are the benefits of GLOSA? Well, from a TomTom perspective, and I'm sure Miovision understands the same opportunities here. There's an opportunity to incentivize smoother driving, so reducing start-stops in urban areas, to take into account other vehicles and flows by time of day. I lived for a while in South America, and in South America, the drivers are not patient when it comes to red lights. And so as soon as the light would change to green, everyone would be on their horns, even though they were 200 meters from the intersection, and everyone else would have to move first in front of them. So smoother driving is a clear opportunity for GLOSA to improve people's driving behavior. It reduces wear and tear, obviously, as a result. So reduces your level of braking, the demands on powertrain, acceleration, deacceleration. It reduces your fuel consumption because you don't have to stop so often, and that's particularly the case with heavy vehicles. A large percentage of urban emissions is related to buses and trucks and heavy vehicles accelerating and deaccelerating within urban environments. And brake dust, of course, is even more of a problem than CO2 or pure emissions from the tailpipe. So I think overall GLOSA seeds better driver behavior, and with better driver behavior, smoother speeds, obviously there are safety benefits for road authorities. There are safety benefits from the manufacturers of vehicles perspective, and also for insurers. There are benefits in this technology if it's applied widely at scale. One of the benefits that TomTom brings to this, as Thomas mentioned, SD SPaT messages. This can be undertaken. These SPaT messages can be generated through virtual detection mechanisms, and TomTom collects GPS data from millions of vehicles every day, and millions of unique GPS devices, and that allows road authorities, allows those programming signals to update signal timings and to optimize those signal timings for maximum flow of traffic at peak times in and out of the city. So it has huge societal benefits when applied at scale.
Great. All right. Thanks for the wrap up and the summary. Let's have a quick look at some of the answers that people gave. So what do you think GLOSA can do for your use cases? I think you've touched on some of these already. Improve fuel efficiency, increase safety. There's one here about it doesn't really sound like anything for people outside of private cars. I think obviously private cars is going to be a big one, especially as Thomas described with the Audi scenario of the system being in there.
But also, as Doug said, the heavy trucks, the heavy vehicles actually have a much bigger benefit, because if you can save one heavy truck from stopping, you can measure, this is not cents, you measure it in dollars or pounds or euros, whatever you want. It's significant, the savings there.
Yeah, absolutely. I think trucks was the one that really kind of stood out in that kind of roundup at the end. Time and fuel,
just one other thing on that discussion about private car users. I think this has benefits to vulnerable road users as well. So if you imagine that at the moment vehicles approaching too fast might try and jump a red, if you know in vehicle that it's turning green, or that it's red up ahead and there's no chance, then that actually enforces good behavior and reduces the chance that a pedestrian crossing would be pedestrian crossing the road might be hit.
Yeah.
So I think it has impacts for vulnerable road users as well. And
It's an interesting one. I don't know, Thomas, whether in the scenario that you described with Audi or other scenarios, you show the scenario of approaching the light and maintaining a speed to switch to green. I'm guessing, does it also work reverse, where it tells you red light is going to come on, you now need to start reducing speed?
If I had left, 20 seconds later in that same approach, it would have told me way in advance, don't even bother. As Doug said, basically, don't even bother. You're not going to make it.
So I think they're really for the safety angle, and also as we move into kind of more vehicles, using self-driving technology, etc., that can then become an automated process where the car automatically starts to deaccelerate as it approaches those lights, knowing, maybe even slowing enough that actually when they get within 5-10 meters, it's ready to change again. So actually, it keeps that flow moving forward. But thank you for your thoughts, your inputs. It definitely brings a few ideas and maybe reinforces some of the things that Thomas described. So let's move on to the next. Area. So really now it's looking at how does traffic, both real time and historical, enable the V2X system. So maybe let's kick off, Doug, with you this time, and maybe can you talk a little bit about maybe what some of those kind of key benefits are?
Sure. So I mentioned a few minutes ago that we collect data from millions of GPS devices around the world every day, several hundred million trips within the US alone every day, and that GPS data is just one part of the picture of driving behavior. So thinking to the wider opportunity of GLOSA and SPaTs and intersection level data, I think it's a really exciting time for connected car data to be used in what's called V2X or V2 everything communications, and using that information, that communication channel to drive live traffic management. At the moment, the picture is a really mixed one out there for the V2X market. There are a whole range of different players and actors in the picture. So DOTs, road agencies, road operators, they have a very incomplete picture of their road network. And as Thomas mentioned earlier, hardware sensors are both expensive to install, expensive to maintain, and as a result, they're often unreliable for monitoring and managing the road network. From looking specifically at signals, not all signals are connected. In fact, more than 60% are fixed timing in the USA. In Europe, more than 60% are automated and active adaptive signals. So in order to connect the driver to the infrastructure, or to manage and influence the infrastructure as a road authority, we need to make that connection more closely. Vehicles, it's all right for Audi drivers or for other high-end vehicles with this connection, but most vehicles at the moment are blind to traffic signals, and but vehicles are becoming an ever more powerful sensor in themselves, and software-defined vehicles are really built on a foundation of hardware, sensors, and software, and part of that is about communicating data back to data providers and navigation providers like TomTom, but also about being able to make that connection to road authorities and drive traffic management strategies or reactions and decisions. And then there's services, a kind of layer in here, which is about pulling together many different sources of data and using those to provide services that can be used, modular services that can be used as components of the vehicle, as components of navigation, of routing systems, of route planning and scheduling for fleets. So really the opportunity is about combining hardware services at intersection, the opportunity is to optimize flow in cities, as we talked about a moment ago, in terms of GLOSA, to reduce delay, accidents, and of course emissions. And really, TomTom's at the heart of enabling that. It's infrastructureless detection and monitoring of delays at intersections. We have historic data to enable an understanding of behaviors at intersections, between intersections, and across the wider network. And that's a really powerful basis for services like the Miovision service. So just to give you a picture of what this looks like, on the left you can see an image of raw GPS probe data, directional across the road network. There's a delay on a freeway, and there's an intersection just off the freeway, which is represented on the right-hand side by a service, a live junction or intersection analytics service, and that allows us to derive turn movement ratios, the delay on this approach, the number of stops, the travel time across this approach, and the number of vehicles, or to make an estimate of the volume of traffic across that approach and every other approach up to the intersection.
And color you said was direction, not volume, right? So direction of vehicles.
Yeah, exactly. Direction or trajectory angle. So yeah, we take the data, we turn it into information and then into a service, and that service can be used by partners and providers of value-added services like Miovision.
And so then, yeah, a great segue then onto Thomas then. So once you've got this data, how does Miovision then what are the services that you build around this?
Let me say, since we're talking about V2X, right? V2X has been and I think I mentioned it earlier already, in discussion in the profession, in the industry for, I think, over 30 years. I think I was in graduate school in the early 90s when we already talked about the subject. But it hasn't really broken into the mainstream, right? And so Miovision's game plan is and vision is really to make V2X a reality, a day-to-day reality for everybody, not just for very sporadic intersections, sporadic users, but really a day-to-day experience that becomes ubiquitous for everybody. And we've basically laid out a game plan for that in terms of having a whole product suite that has 4 different bundles. In each one of those bundles is geared towards, covers use cases, if you so will, that are geared towards individual respective customers. So the first 2 you see up here is the convenience and optimization bundles. Those are the bundles that are really focused on the drivers. We just talked about it. The GLOSA part is a very important one, optimizing the approach to an intersection for drivers. On the left side, you see the time to green. That is usually the counterpart that when people talk about V2X right now, or if you look at an Audi, for example, well, let's say you are a red light and you want to know how many seconds do I have to wait before it turns green. That's the time to green. So typically time to green, GLOSA go hand in hand. But you see there's more use cases under those. For example, the next one under optimization is personalized green light or signal traverse optimization, depending on how you want to angle it. And that is an important aspect where we actually have the vehicle now drive and influence the signal system in the reverse direction, where each individual vehicle becomes a probe vehicle in a detection item, if you so will, by itself, influencing the signal system and therefore further improving flow and reduce wait time for the vehicle itself. Having said that, this is really what we look at scale, right? At very large scale. However, we have intersections. Obviously, VRU safety was brought up earlier, is an important topic. And we have, of course, intersections where safety is a concern and is a big problem. And so for those intersections, we're focusing on providing at the intersection through hardware equipment, localized detection, for example, red light violation warning, dilemma zone assist, and white alert as a broadcasted alert message to influence and prevent in short range, if you so will, accidents. If we predict that in the next 3 seconds, 2 vehicles or a vehicle and a bicyclist or a vehicle and a pedestrians are in the same space at the same time, that's a problem. We need to, in the technology exists, everything is here to then alert and influence and basically prevent this kind of an accident from happening in the first place. Long story short, it's basically geared towards providing a lot of use cases. Some of them are focused and driven by agencies. Safety is usually an agency concern. Vision Zero is something that most agencies have as their #1 policy for traffic, local traffic. And then, of course, convenience and optimization, fuel reductions, efficiency, all of those are use cases that are more, let's say, operator focused and driven by the people who actually drive or get through intersections themselves. That, back to you, Andy.
Kind of sounds a little bit almost like air traffic control for road users, right? I think you say about being able to predict and see people in the same space. It's almost taking that concept but putting it into, feet on the ground, tires on the road, etc.
Absolutely.
And particularly as vehicles become more autonomous and have more advanced driving assistance features, that's really important that we make the connection between these between hardware, software, and the vehicle itself.
Okay, back to our audience then. So knowing what you know, thinking about where you drive, what you do, etc. So how do you rely on this type of real-time or predictive travel data on your daily commutes? Again, pop your answers in and tell us a little bit more about how you get the benefit from these. And while people do that, also please add your questions. We're coming up to the Q&A towards the end. So please don't forget to add any questions that you've got to the right-hand side. But maybe for me, I think I found over the past few years, and I think this is probably very common to a lot of the kind of traditional TomTom user base, is that actually, your navigation device that's in your car, your navigation device on your phone that's maybe sat on your dashboard, etc. I think I probably use it less for the navigation component, but definitely more for the traffic element, as in, do I know I'm going to get to pick up my kids at school on time? Do I know I'm going to get to, the restaurant on time? Or am I going to reach my flight on time if I'm traveling to the airport, etc.? So I think it's really, I guess the traffic has become almost the use case of the navigation now, because most people on a daily basis, on a regular basis, know how to get from A to B. But what they don't know is what the traffic is doing from A to B and where it may affect them. I mean, I guess, Doug, we work reasonably closely together. I guess you probably see similar patterns, right?
Yeah, absolutely. I think particularly post-COVID, where there's been a return to normal, kind of more normal operating conditions. Still with more hybrid working, it's less about the same patterns, but again, it's more stochastic. Basically, it's become more unpredictable on the road network to key origins and destinations, and so that's where real-time data and predictive data really helps.
So
the daily commute is not quite so.
Yeah, we've obviously got a view, from a similar location. But Thomas, what about where you are?
Same way. I mean, at the end of the day, you use your alerts all the time so that you know what happens if there's incident alerts, etc. Obviously, as you saw the video earlier, I have the benefit that I actually get to experience GLOSA and red light countdown on a daily basis. I live also in an area with very high and good coverage, and I can tell you that changes your behavior as well. This is something that obviously we're talking about here, but when you do it, when you actually do experience it, you miss it. You come to the next signal where it doesn't have the data, etc. You already start missing it, and that goes back to be honest, all the way when we first developed the first prototype 10 years ago with Audi in Las Vegas. we drove in 50 signals, a small area, and as soon as we left the 50 signals, everybody's like, where is it now? And because we had just left it, and you get so used to it, and it becomes part of how you drive.
Interestingly enough, though, when you're driving and you don't have it, so this, it's not available in that area, or the signals aren't. Do you find that it alters your driving behavior? Do you still drive in the same way, as in you're imagining or you're predicting that it's going to change within a certain
The
time?
joke is you never drive the same way again. Because
better, I hope.
Yeah, I think it reinforces good behaviors, right, Thomas? I think it does.
You look at it and you try to. I had a colleague from Audi. He once said it's part of your fixed audience, your captive audience, and that's the only entertainment you have when you're looking at a signal. You're not allowed to take your phone out anyway. Assume you don't do that. So then what are you gonna look at? Oh, I can look at a red light countdown. That is really good entertainment at that moment, because that's what else am I gonna do, right? Or I can tell you in Vegas often, right? You have 150-second cycle length plus. You wait and you wait and you wonder, does anybody see you? Hello, I want to get, and having that countdown gives you at least that comfort that yes, you're going to wait another 20 or 60, 120 seconds. Eventually, this countdown will go into 0 and you actually will get green. Yeah. So that is part of that live entertainment at the light.
Nice. Let's maybe have a look at the poll and see what people thought. What were people's? Let's have a look. Find the fastest route. Yeah. Route selection, adjusting time of departure, high traffic areas, arrival time. Yeah. Improved navigation, adjusting speed, and knowing time to green, 25 checks of route, phone messages. Yeah. I mean, if you're sat at the light, I guess, and you can see it's got a countdown of 35, 40 seconds to change to green, then yeah, it gives you the opportunity to I guess check your phone if that's legally allowed, or take a drink, or grab a sweet, or whatever you do, and you sat twiddling your thumbs waiting for the colors to change. Don't. Okay, that's also good. That it's not used. Cycling to work, I guess. So maybe that's another use case in the future, right? Of connecting with bicycle applications and etc. Especially the point that I think Douglas made earlier with the safety point of connecting bicycles, maybe riding with an application for cyclists, and knowing where those and potentially vehicles are going to come into a too closer proximity at some point. Maybe that's additional use cases in the future. Okay, great. Thanks again for your input and insight. And let's move on to kind of the last topic now, and let's try and kind of bring it all together and see where these opportunities lie. So, I think it's obvious that between TomTom and Miovision, there's a real range of products and services, both for road authorities, departments of transport, highway companies, OEMs, drivers as well. But Doug, how would you kind of summarize, what the opportunity is and where we kind of go forward from TomTom's perspective?
Sure. Yeah. So I guess the first step has been enabling Miovision to build and maintain and improve the TTS solution in GLOSA, in the GLOSA environment for in-vehicle. But of course, Miovision, as Thomas said, is a company with leverage and influence in a wide range of areas of traffic management. And so the next step for us in our partnership really is about enabling Miovision to do more. I mentioned earlier that this is not just at intersections which are not equipped with hardware. We can give them visibility of those intersections and the movements there and the performance of those intersections. So I think virtual performance management, or virtual automatic traffic signal performance management and measurement is one one of the next steps. And the other area, of course, is between those intersections. Having an understanding of movements and travel times between those intersections helps road authorities, DOTs, decide where to implement adaptive traffic signals, where to target road improvements, capacity improvements, where perhaps to manage speed. We have mentioned it in passing here so far. But those are kind of next steps for the partnership and working together, providing both live and historic data to inform targeting, traffic transport planning, and traffic management. Effectively, building from that digital twin to more applications.
All right, great. And Thomas, what about Miovision's outlook?
Yeah, I think let me piggyback directly on to what Doug had said. I mentioned earlier already, deployment scale is the number one, focus for us, and obviously, therefore, the integration with TomTom and the SPaT across almost every intersection as possible is a high priority. Having said that, our mission really is around what we call the smartphone of the intersection, right? We used to all, Andy, as you joked before, it gives away your age when you know that what a Nokia phone was, when you know what a flip phone was, when you know what a BlackBerry was. But there's some truth to it, right? In the past, we used to carry 4 different devices, flip phone, Nokia, BlackBerry, Lotus for notes, and then, of course, don't forget the camera, the point-and-shoot camera. All these devices were individual hardware, software devices that we carried with us. Now we have one. It's called a smartphone. And we strongly believe that you don't get to V2X at scale at this higher level definition down the road if you don't have some form of uniformity of hardware at the intersection. So that is a big piece of our strategy moving forward to make this a reality. And then tie you back into what Doug said. In the end, it has to be a combination of physical and virtual sensors, right? Because in the end, that's what drives any information, any knowledge of what we are trying to accomplish, and through of real-time picture, we create the predictive, which is where the true value lies. And to do that, we have a combination of, as I said, physical, optical, video detection, whatever it is, physical sensors, vehicles themselves, and that becomes therefore virtual sensors, and they all create one image, one picture of the reality that's happening right now to create the future, to create the forecast.
Okay, and Doug, maybe quickly, 30 seconds. What's next? What does the future look like beyond what we can see today?
Yeah, so I mean, building that digital twin, building the capacity to with the help of things like artificial intelligence and certainly machine learning. We're already using that in many areas of traffic management, and so building that digital twin, and also enabling it, as I mentioned earlier, in software-defined vehicles within the navigation space, enabling fleet and logistics and ride-hailing partners to better estimate their travel times. So lots of areas that this complete picture and dynamic digital twin enables. I think also to give some insight into planned developments, we're looking to understand road safety risk better, and combining data from road authorities together with the map and map attributes and live data and historic data, for example, hard braking events. This is the type of information that we have, but we've not surfaced to date. So it's a very exciting time, as I said earlier, for traffic management. It's very exciting to bring together partners with these capabilities, to bring together hardware and software, and improve the picture and improve the ability for road authorities to influence and manage their road network. The hardest one to crack is managing demand, and and reducing demand. But that's
okay. So before we kind of move on to the Q&A, Thomas, I'll give the last word to you then on what the future looks like from Miovision's point of view.
Yeah, I kind of sort of wrapped both of those earlier into one answer. I think the future is that, how do I say that we don't have just one intersection that has all the cool bells and whistles attached to it, but that we have a really good mix of, you know, if there's an intersection right now that has a span wire cross diagonal with 4 different signal heads in 2 directions and it's running fixed time all day long, that also is an intersection that needs to be part of our plan of coverage. So the point being, it needs to be covering everything at different scales and different use cases and different levels of fidelity, because only then can we get to this true interactive mode of vehicles, pedestrians, VRUs, and cities all working together. And that's what you call smart city at the end of the day, right? That's what it is.
Yeah, great. All right, thank you both. Looks like we've got some questions in there, so let's jump into some of those. Let's see if I can get these questions up.
Yeah, lots of them.
All right,
cool.
First one. How do you see cities and DOTs using GLOSA to manage emission regulations? I don't know which one of you wants to tackle that one.
Oh, that's a
Should we start off with
good
a hard
one? That's a very difficult one because that touches into regulations. And
all right, maybe let's adapt it. Do you see cities using this to manage emission regulations?
Yeah, I think that's a national and international level. I think those, clearly in the EU and in the US, there are targets to reduce fuel, improve the fuel consumption of vehicles, and also to incentivize ownership and usage of electric vehicles. I think another area that needs to be covered at national level through regulation is improving utilization of vehicles, and that in particular favors ride-hailing. Ride-hailing is a much more efficient use of vehicles at the end of the day. So in terms of managing emissions, yeah, obviously it would be great if GLOSA was mandated for vehicle manufacturers at a national level. I don't see that happening very quickly, but I think it's going to come hand in hand with autonomous driving and vehicles that are ever more connected and used for that.
Thomas, any
but I
great
think
question.
You can do it. I would think, thanks Doug, just piggybacking on that, I think it's more of a carrot rather than a stick, in a sense of you can give, first of all, cities, it should be a part of the toolbox.
Yeah,
and from cities, and the first thing they need to do and should do is open up their data, because without their data it can't happen. So that's the first part. Make data available to companies such as ourselves here, so that we can make the service available to others, to road users, etc. And from there, then you can go and say, hey, vehicles that are equipped with this kind of technology, for example, especially coming back to what we started out with, heavy goods vehicles, trucks. The city fleets themselves are a big user of their network, right? All of those, and you can then give them priority. You can give them reduced tax incentives, whatever you want to give them a carrot to further incentivize this.
Okay. All right, let's look what else we've got. I think next one maybe for you, Thomas. REMS services, I'm guessing that's emergency vehicles using V2X data. Do you know if that's the case?
I would say, for the most part, when you deal with EMS, you deal with preemption, or as we would call it here in the US, right, or in North America, signal preemption, and so in other words, a fire truck doesn't want to know what speed to approach a signal to minimize stops. The fire truck wants to get the signal to turn green before it gets there, and ideally get anybody out of the way.
Green corridor,
so,
right?
I would say that do they use VTX technology? Absolutely. And I think I mentioned earlier, we are actually one of the, if not we are the market leader in that type of technology for emergency vehicles, certainly in North America. but they are not necessarily using the data. They're influencing the data because, of course, their presence is a part of the data we want to share to everybody else so that they're aware of them.
Yeah. Okay, great. Next one. What areas are covered by your maybe by your services, right? Is it mainly the North American market? Is it European market? What kind of areas is your service available in?
Yeah, it's at the moment it's heavily focused, if you so will, biased towards North America, and we have coverage. I want to say I forgot in the US, like 40 out of 50 states or something like that. We have covered, and in Europe it's a little bit more individual cities. But the focus and the game plan is to dramatically increase this coverage over the next 2 years, so that we exceed 50% coverage in North America, going all the way to 100%, as I mentioned earlier. That is the goal. That is an ambitious goal, but it is the goal, and that's where we're working towards.
Okay, thank you.
And just to say, that's obviously facilitated by the partnership with TomTom. We have these services alive and historic in 82 countries around the world and every road segment. So
I think we've probably got time for a couple more questions. Are the tools only being used to optimize car travel or also walking and biking? I'm not clear whether green light also includes walk signals.
It doesn't. I mean, for bikes, yes, of course, you can provide bicyclists the same information and say, hey, cruise now because you're not going to get green. However, I would say from a technology perspective, the benefit for bikes and pedestrians is indirect to the savings, the better driving behavior, as Doug mentioned earlier, right? You pointed that out. If you have safer driving for vehicles, we have automatically safer operations for bikes and walks. But what I didn't mention is part of this whole exercise or this whole development of the smart city, the smarter intersections, etc., is to make, let's say, detection green lights more approachable for bikes and pedestrians, because especially if you're a bicyclist and you have just take an aluminum frame or carbon fiber frame and you have a city that uses inductive loops, you can sit on this loop all day long. You're never going to get green because you don't have enough metal on there to trigger the induction. So all of that technology has two-way communication, and therefore influence and enable and improve life for pedestrians and bicyclists as well.
Yeah. All right. Maybe last question then. Unfortunately, and we'll have to wrap it up there. Sorry if I missed this, but does Miovision ingest data from TomTom to augment the capabilities, or is it more of a side-by-side deployment where TomTom fills the blanks without Miovision deployments?
It's more the latter, right? Yes, we basically, as I said earlier, we use TomTom as a virtual sensor. That's really what we do. And at the end of the day, but because it's virtual and because it's at scale and because it's global, that becomes that opens up tremendous opportunities from a deployment perspective.
Okay. Guys, I think we're just about there. Unfortunately, it seems to have flown by the last 60 minutes. But thank you for your company, Doug. Thanks for your insights from the TomTom perspective, and obviously Thomas, all of your knowledge and insights from Miovision. For those listening, I hope it's been entertaining. Let's call it. Maybe traffic isn't seen as the most exciting topic, but I think you can see there's a lot of technology, there's a lot of innovation that really kind of changes how we interact with the things that we perhaps take for granted when we drive day in, day out. But if you want to know more, or you have further questions, or you want to talk to Miovision or to TomTom, then all the details are there on the screen right now. If you didn't get the answers that you were looking for, we will try and respond to all the questions after this. But for now, thanks for joining us. Thanks for listening, and have a good evening or rest of the day wherever you are.
Thanks very much, everybody.
Thank you.
Yep.
Bye bye.
Thank you. Bye bye.